everyone, Mrs. Spatola here. Today we're going to start with a warm-up. Before we start to simplify fractions, we're going to find the greatest common factor of a few numbers for the first couple of problems, and we're going to use the T-chart method. There are two different ways that we can find the GCF, as we saw yesterday. One is using the T-chart and a list of prime factors, and the other way is the prime factorization. Well, if you like the prime factorization method, please by all means go ahead and use it, but we're going to focus going forward on using the T-charts. So what I'd like you to do right now is using the T-chart method, try numbers 7 and 8 on your own. Please pause the video, give it a shot, and then check your answers. If you completed number 7, we're going to check our answer. So when you're finding the GCF of two numbers, you're going to go to the smaller number first and go through your list. Is 12 in both of these numbers? The answer is no. Is 6 in both of these numbers? The answer is no. Is 4 in both of these numbers? The answer is yes. Is 2 in both, is 3 in both of these numbers? The answer is no. Is 2 in both of these numbers? Yes. And so is 1. So when you're looking to find the GCF, you're looking for the biggest number that both of the given numbers have in common. So the GCF, or the largest number in both charts, is going to be 4. Let's try number 8. Please pause the video. Okay, for number 8, what you're going to do is we have the GCF of 20 and 36. We're going to go start with the smaller number and check your list to see if both of the numbers are in each of the factor lists. So start with 20. Is 20 in both of them? The answer is no. Is 10 in both? No. Is 5 in both? No. Is 4 in both? Yes. And you have to be very careful and make sure you're looking at both of the lists. Is 2 in both? Yes. Make sure you circle it. Is 1 in both? Yes. Alrighty, here's the key question. What is the largest number that you circled in each of the two factor lists? You will see that the greatest common factor then, is the number 4. By the way, when you're making your factor lists, notice here in 36, when there is a double, only list one of the numbers. And then for the other one, consecutive numbers, you're finished. When you have consecutive numbers, that means that one number is after the other. So for example, 4 and 5 are consecutive numbers. The GCF, again, for number 8 was 4. Today's lesson, Unit 4, Lesson 5, is simplifying fractions and finding equivalent fractions. How can fractions be simplified and shown as equivalent? Well, you've seen this in the past. However, in 6th grade, we will find that we can simplify fractions in two ways. One is doing it mathematically, using the greatest common factor, and using factors themselves. And another way is simply to use the calculator. However, right now we're going to be focusing on using the greatest common factor or factors to simplify fractions. Well, let's take a look and see how we can do that. Over on the right-hand side, I love my little comics here. We have, I believe this is from a cartoon called Family Circus. We have a little boy and a little girl. The comic reads, "Wait a minute, why did PJ get 4 sandwiches and I only got 2? Well, if you take a look, what do you notice about the size of the actual entire sandwich? Yeah, exactly. They're the same size, except they're broken down into more parts. By the way, my kids always like especially their peanut butter and jelly sandwiches, they always like their sandwiches cut into 4. I don't know about you, but for some reason they always felt it tasted better. Let's move on with the lesson. Today I'm going to ask you the do now question. We are not going to be responsible for that, so actually I'm going to have you just cancel that out. We are definitely not using that particular question. Let's get on with the lesson. Moving on, we can see when the numerator and the denominator of a fraction have no common factor other than 1, The fraction is what we call, do you remember this from elementary school? The fraction is in what we call simplest form. That means that there are no common factors in the numerator or in the denominator of the fraction. So when we simplify fractions, we are going to find the GCF of both numbers, divide the numerator and denominator by that GCF, and basically we're done. So for example, 4/8, the greatest common factor of 4 and 8. Now for this here, you're going to want to make your T-chart. Some of you can see exactly that 4 is the biggest number. You think to yourself, what's the biggest number that can go into 4 and 8? Well, 2 is definitely a factor, but it's not the biggest. I would suggest, and what we're going to be doing just for the time being, is we're going to be making a T-chart. So it would be 1 times 4, 2 times 2. For 8, it would be 1 times 8, 2 times 4, and that's it. Because if we go 4 times 2, it's the same thing. So the factors of 4 are 1, 2, and 4. The factors of 8 are 1, 2, 4, and 8. The greatest factor of both, so in other words, in these two lists, the greatest common factor is 4. So we would divide by 4 over 4, and then our final answer is 1/2. If we look at this example here, the second example here, you would see 20 over 36, the greatest common factor. Again, if you made your T-charts, the simplest form representation would be 5/9. Let's keep going. So the directions for numbers 1, 2, 3, and 4, it says, find the GCF of the numerator and denominator to simplify the fractions. So what we're going to do is we're going to find the GCF of both the numerator and the denominator by making T-charts. We're going to make our little T-charts, and then we're going to show our work. We need to understand how to simplify fractions before we move on to use the calculator. Now, you can use the calculator to check it. We will talk more about that in class. So for now, what we're going to do is for number 1, we have 18 over 24, and we're going to make a T-chart. Make your T-charts for both 18 and 24. Pause the video now. Now that you've made your T-charts, go on and list your factors. So for 18, we're going to just list the factors in order from the T-chart. So it's 1, 2, 3, 6, 9, and 18. Now for some of you can actually use the T-chart and compare the T-chart. We found that was a little tough for some boys and girls, so the best way to do it is after you make your T-chart, just list out the factors. It keeps everything organized. It's a little bit of an extra step, but it keeps everything organized, and it will help you to be successful and to also make sure that you get all of your factors listed. Okay, this is 24. All right, so when I compare 18 and 24, I see that 1 is in both. I see that 2's in both. 3's in both. Is 4 in both? No. Is 6 in both? Yes. 9 in both? No. 8 is not in that one. 18. All right, so I think I'm done here. So for this here, the GCF is equal to 6. So the biggest number, okay, the biggest factor that goes into 18 and 24 is 6. Now what you're going to do is we're going to shift our focus over here. We're going to go ahead and divide the numerator and denominator by the GCF. This 6 here is the GCF. So when we're doing that, all we do now is 18 divided by 6 is 3, and 24 divided by 6 is 4. So guess what? Our final answer is 3/4, and that's it. It does take a few minutes to get it done, but let's do the next one. Let's go ahead and do some practice here and see how we do. The next one is 12 over 36. Sometimes you can look, and you can actually save yourself a lot of work. You can look and ask yourself first, does the numerator go into the denominator? Well, watch this. For 12 over 36, if I ask myself, hey, does the numerator, 12, can that be divided into 36? Well, if you know your multiplication facts, you would say yes. So guess what? You can almost avoid all of that hard work and just go like this. Watch. The numerator is 12. I'm going to divide the numerator and denominator by 12. Holy shortcut. 12 divided by 12 is 1. 36 divided by 12 is 3. And guess what? I am done. So before you start making your list now, ask yourself, does the numerator, can it be divided into the denominator? And if so, that is automatically your GCF. Let's go on to number 3. Number 3 is 15 over 24. Now, first thing I'm going to ask myself, can 15 be divided evenly into 24? And obviously, I know that answer is no. So what does that mean? That means I'm going to have to go ahead and I'm going to have to make a T-chart. Look for room, boys and girls, on your page. If you need to do it on separate paper, that's fine. Or just find there's additional boxes at the end of the unit that you can use to help yourself if you need some extra space. So for 15, go ahead actually and do the prime factor charts for 15 and 24, and then we'll come back and see how you did. Find the GCF. Go. Pause the video. Once you make your T-charts, go through the list and see which is the greatest common factor. I see that 1's in both. I see that 3 is in both. 2 is not. 5 and 15 we're done. So the GCF here is going to simply be 3. So my GCF, my greatest common factor, the biggest factor in both 15 and 24 is 3. So the next thing I'm going to do is divide 15 and 24 by 3 over 3. And I find in simplest form, 15 divided by 3 is 5, and 24 divided by 3 is 8. So my final answer is 15 over 8, okay? So remember, basically what you're doing when you're simplifying fraction is you're rewriting with literally, without changing the value, but you're listing it in a different way. Let's take a look at the next problem. Try the next one, number 4, on your own, 14 over 63. Well, if I go ahead and do the math, I know that 14 cannot go into 63. So what I'm going to be doing here is I'm going to be making a T-chart for 14 and for 63, and I'm going to find the greatest common factor. I can actually kind of see it in my head already, but I'm going to go ahead and make my T-charts and find the greatest common factor and simplify. Try this one on your own, see how you do. Pause the video now. All right, I made my T-charts. I have my factors listed. I'm just simply going to go through them and find the greatest common factor. I see 1's in both, 2 is not, 3 is not, 7 is. I think that's it. 14, nope, and that's it. So for this one here, my GCF, my greatest common factor, is 7. That does not look like a 7. There we go. So now what's the next step? I divide my numerator and my denominator by the greatest common factor. 14 divided by 7 is 2, and 63 divided by 7 is 9, and I am good to go. Looking at the notes on the rest of the page, when you simplify fractions, each of the fractions are what we call equivalent, which is another word for equal to each other. You can be sure that fractions are equivalent when their cross products are equal. They're cross products. Well, let's take a look and see what that means. Turn the page. At the top, equivalent fractions, the definition, fractions that name the same amount of the same part of a whole are called equivalent, please write that down, equivalent fractions. All right, let's take a look and see what this looks like. Okay, now to create equivalent fractions, we just simplified fractions using the greatest common factor, but now we're looking to find equivalent fractions. Well, let's see how this works. Step 1 says, it's like our little math recipe here, multiply or divide the numerator and denominator by the same number. Look at the examples provided here. In the first one here, if I wanted to make a an equivalent fraction, 3/4, I can multiply the numerator and the denominator by the same amount. Now notice, earlier in this lesson, we simplified fractions by dividing by the same numerator and denominator, and in that case, that was the greatest common factor. Here, we're going to be multiplying the numerator and denominator by the same one to get equivalent fractions. 3/4. Now notice they're multiplying by 3 and 3. That gets us 9/12. I just want to bring this to your attention here. A way that you can find out if the fractions are equivalent or not. This is huge. And like I said, you've probably seen this before. This whole lesson is pretty much a review lesson. So if it's 3/4, check this out. They have 3/4 equals 9/12. If I wanted to check that to make sure, well, I could simplify 9/12, but we use something called the cross products to see if they are equal. Now, what does that mean? Some of you may have heard it as the butterfly method. Holy cow, now she's bringing butterflies into the lesson. Well, yeah, let's take a look. Or the bow tie. So check this out. Cross products would be going across. What's 9 times 4? 9 times 4 is 36. Now let's go the other way. 3 times 12. What's 3 times 12? It's 36. So when I see that the cross products are equal, is 36 equal to 36? Yes, it is. That means that the fractions are equivalent. So when the cross products are equivalent, that's another way that you can check to see if fractions are equivalent or equal. Let's look at the next one. 2/3 equals 8/12. So if I want to see here, so notice they multiply the numerator and denominator by 4. So 2 times 4 is 8, 3 times 4 is 12. We have 8/12. So let's say, I'm going to scoot this over to the other side where I have a little more room. If I want to see if 2/3 is equal or equivalent to, I'm going to do this one in red. 2/3, is that equal to 8/12? If I just want to test it or check it, I look at the cross products, 8 and 3. What's 8 times 3? 24. What's 2 times 12? It's 24. That's another way that I can check to see they are equivalent. Why are they equivalent? Because their cross products are equal. Okay, let's go down to number 5, 6, and 7. Let's give those a shot. The directions say, write 2 fractions that are equivalent or equal to each fraction. I'm only going to have you do one, so let's just cross that out and let's write 1. Okay, so 5/6. Here's the easiest way to do this. If you are looking, if it's already in simplest form, 5/6, if you're looking to make an equivalent fraction, here's a simple way to do it. Ready? Just multiply by 2/2. So if it's 5/6 and I multiply by 2/2, that equals 5 times 2 is 10. 6 times 2 is 12. There you go, an equivalent fraction. Okay, 5/6 equals 10/12. That is an equivalent fraction. 15/30. Now, you can either multiply or you can divide if you want. So for 5/6, by the way, if you wanted to test that, you could put it in the calculator. We'll look at that, like I said, in the class. But here, let's just, before we move on, 5/6 equals 10/12. Let's test that. Are the cross products equal? 6 times 10 is 60. 5 times 12 is 60. Are they equal? Yep, that just proves, and that's another way to check that they are equivalent. Okay, let's move on to number 6. For number 6, I can see that 15/30 is another way. I know that 5 can go into both of them, so guess what I'm going to do? Very simply, I'm going to divide on this one. I'm just going to divide by 5/5, and my equivalent fraction, 15 divided by 5 is 3. 30 divided by 5 is 6, and that is an equivalent fraction. For this one, I didn't say to put it in simplest form. You might look at that and go, well, it's not in simplest form. Well, that's not what they were asking you for this one. They just wanted something equivalent. Okay, try number 7. You know what? Number 7 we'll just do together. We're going to multiply by 2 over 2, and our final answer is 14 over 16. Okay, let's see what the rest of your assignment is for today. Your job for today is to go ahead and complete numbers 9 through 20, put them in simplest form using the greatest common factor. Be sure that you are using the greatest common factor because that's the only way it'll be in simplest form. Now, tomorrow, hopefully you're listening, tomorrow we do have a quiz. So very quickly, some of the things you need to know. Ready? And you might even want to pause the video or replay this and write it down. Vocabulary terms: product, factor, prime number, composite number, greatest common factor, equivalent fraction, prime factorization, divisible. Some of the things you're going to need to know how to do is to find the prime factorization using a factor tree for a number. You're going to need to find the Gcf of two numbers using a T-chart. You're going to need to know whether a number is prime or composite. And then the last thing you're going to need to do is to be able to tell if I give you two fractions, you're going to have to say whether they are equivalent or not. And for that, all you need to do is check the cross products. There are going to be 10 basic questions, and it's only going to take a short time. And then we're going to go on and learn more about greatest common factors with word problems. Yay! All right, this is Mrs. Spatola wishing you a great day. And remember, always, always be kind.